Okay, so now in this section what we do is we'll try to evaluate the uncertainty product delta x delta p for the harmonic oscillator. Okay, so we know what delta x square, which is equal to x square average minus x average square. Similarly, delta p square is equal to p square average minus p average square. Okay, so now we need to evaluate x average value of x, average value of x square, average value of p, average value of p square. All these things we need to compute. And first we start with, so we can write x as square root of h cut divided by 2m omega into a plus a dagger. And similarly, p is equal to I into square root of h cut m omega divided by 2 into a dagger minus a. We already evaluated this. Alright, if that is the case, average value of x with respect to the your n state is going to n xn, which is equal to x square root of h cut divided by 2m omega, which comes out, 2m omega, which comes out, and then we have got n a plus a dagger n. I'm not going to evaluate this, but I'll just argue that there is 0. This has to be 0 because if you take a dagger acting on n, that will be take the state n to n plus 1 state, and n and n plus 1 they are orthogonal states, so that term won't contribute. Similarly, a will take n to n minus 1 state, so that will also be 0. So that's 0. Similarly, the average value of p is np n, which is equal to I into square root of m h cut omega divided by 2 into n a dagger minus a into n, say n. Again, on this context also it has to be 0, right? Because this a takes to n minus 1, and again similarly a dagger takes it to n plus 1, so when you take this thing it will be 0. Alright. So now we need to evaluate. So x and p both are 0. So say average value of x is 0, average value of p, that's also 0. Average value of p is also 0. Now let's try to evaluate n x square, that means average value of x square n. This is equal to, if you square it, so you have h cut divided by 2m omega into n a plus a dagger all square n. Okay, but this is equal to h cut divided by 2m omega into n a square plus a dagger square plus a dagger a plus a dagger. Again, like our previous argument, a square will take this state n to n minus 2 state, so that term will not contribute. A dagger square will take it to n plus the second state, that will also contribute. The contributing terms are these things, a dagger a plus a dagger. But a dagger a is basically n when it acts on, okay, so this will be h cut by 2m omega into n a dagger a plus a dagger. But a dagger a is basically n, and a dagger, a commutator a dagger is 1, and a dagger minus a dagger a is equal to 1, or a dagger is basically 1 plus a dagger a is 1 plus n, so it's basically you will get 2n plus 1, 2 capital N plus 1, or this will be equal to h cut by 2m omega into 2n plus 1. 2 small n plus 1, because capital N acting on n will be small n. So, or we can write here average value of x square is going to be equal to, you put a 2 outside, so h cut by m omega into n plus 1. Okay, now similarly we will evaluate p square. Average value of p square, I'll just do it. So let's evaluate p square. P square will be as a minus. When you square it off, it will have minus 1 minus h cut m omega divided by 2, and then you have take n, then a dagger minus a whole square, a dagger square plus a square minus a dagger a minus a dagger n. Again, as I told you earlier, a dagger square n will take it to n plus 1 state, so that won't contribute. A square will take it to n minus second state, that will also not contribute. The only contributing thing, there's already minus sign, that is minus sign, this minus sign will cancel away. So h cut m omega divided by 2 into, so this will be n to n plus 1. Yeah, right? So this is equal to h cut m omega into 2n plus half. Oh, this is the average value of p square. Average value of p square. Okay? And you can solve these results. So you can see delta x square is x average is 0, right? X average is 0, so you just x square average. X square average, that is equal to h cut by m omega into n plus half. This is equal to h cut m omega into n plus half. So delta x square, delta p square, which is equal to h cut by m omega, h cut m omega into n plus half whole square. Or m omega goes away, h cut square into n plus half whole square. Okay, this is your delta x square, delta x square, delta p square. Okay, our delta x, delta p is h cut into n plus half. And here you can see that for the ground state n equals 0, so you will get delta x, delta p, which is equal to h cut by 2. Okay, this is the minimum uncertainty. The minimum uncertainty is h cut by 2, right? So, because of uncertainty principle, right? Alright, here you can see that this is the minimum uncertainty. So, the ground state of harmonic oscillator is the ground state, the minimum uncertainty state. It is also called the coherent state. The coherent state. Okay. So, I mean, for other states you can calculate like this. So, I think I will stop here this thing, and thank you very much.